trigonometric equations using Pythagorean identities. And so it seems new, and it is, but what in the name is familiar to us? Trigonometry, so we're going to be using trig, we're going to be using sine and cosine and tangent and stuff like that. What else is familiar to us? Pythagoras or Pythagorean. And so when you think of Pythagorean, what is your knee-jerk reaction that you spill out of your mouth? Your Pythagorean theorem, which is your a squared plus b squared equals c squared. And so we're going to use this, and this is going to help us figure out what these Pythagorean identities are. And so if we were just to look at a quadrant of a unit circle, so we're just going to look at the first quadrant and pick just any random point, just any arbitrary point, whatever spot looks your favorite on the unit circle for you. I'm just going to pick this one. And then we're going to turn this point into a triangle. So if you remember, when we started out with the unit circle, we first started using those special right triangles. And we made our unit circle, or we got our values on a unit circle from these triangles. And my triangle looks kind of bad, but I'm sure yours looks better. And so this is just some value on the unit circle, some one that you probably don't have memorized. And so we know that a squared plus b squared, or a squared plus b squared equals c squared, works for right triangles. And so we can label what our a, our b, and our c is. So we have a here, b down here, and then c. So we have a squared plus b squared equals c squared. And now, unit circle. So what is c going to be on our unit circle? C is the hypotenuse, or the radius of the circle. And what's the radius of a unit circle? 1. We call it the unit circle because the radius is 1 unit. And so we know what c is going to be. So we have a squared plus b squared equals 1 squared. And now if we look to what we label, or if we look at what we labeled a and b, we have a as the y value of our triangle, and we have b as the x value of our triangle. So we can swap in y and x for our triangle. So we have, oh, I don't want that. We have y squared plus x squared equals 1 squared. And what's 1 squared? Just 1. So we can. And now, Tracy, you said trigonometry. That's one of the parts of the title that relates to us. So, thinking in trigonometry, what is our trig or what is our trig function that relates to y? Or what? Sine. So we have sine squared x, or I'm gonna write theta. It's just a variable. So it's sine squared of theta. And then what's our x trig function? It's cosine. So cosine of theta. So we have sine squared plus cosine squared equals 1. And this is our trig identity. It may seem kind of bland and I don't know how this is going to help me in life, this little thing. But if you take calculus, this trig identity is going to show up a lot. Especially it's really helpful with simplifying things. And we'll look into that in just a little sec. But there's actually 2 other trig identities that come from sine squared plus cosine squared equals 1. And to find these 2 other trig identities, we're going to take our first one that we just started with, our sine squared plus cosine squared equals 1. Rewrite that. We have sine squared theta plus cosine squared theta equals 1. And we can rewrite this if we just take everything and divide it by cosine. or cosine squared theta. And that even includes the 1, because if we divide one side by cosine squared, we have to divide the other side by cosine squared. So what is sine squared divided by cosine squared? Tangent squared. Because tangent is sine over cosine. And what is cosine squared divided by cosine squared? 1. And 1 divided by cosine squared is the reciprocal of cosine. So the reciprocal partner of cosine is going to be secant. So we have secant squared. So this is our second trig identity. Tangent squared plus 1 equals secant squared. And this is also another one that might show up in calculus. Calc 2 if you take those. So we have sine squared plus cosine squared equals 1. Tangent squared plus secant squared equals 1. And now we have one other. And we take this one by getting sine squared plus cosine squared. Oh, this should be a theta in there. And so the first one we divided by cosine squared. So what are we going to divide this one by? Sine squared. So we're going to divide everything by sine squared of theta. Once again, that includes the 1 because we have to make both sides equal. So if we divide one side, we have to divide the other. And so what will sine squared divided by sine squared be? 1. And what is cosine squared divided by sine squared? It's going to be cotangent. So cotangent is the reciprocal of tangent, and tangent is sine over cosine. So it's cotangent squared of theta. And this is all equal to 1 over sine squared, which is the reciprocal of sine. And what's the reciprocal of sine? Cosecant. So we have cosecant squared theta. And this is our last trig identity. And this one isn't, I didn't remember 1 plus cotangent equals cosecant squared showing up as much in calculus, but the other two were big players in calculus, and they showed up a lot. And so those were our 3 main ones. But we can actually rewrite them into 3 different forms of themselves. And so when they're in different forms, we can manipulate them easier and use them to help us solve things easier. And so to manipulate them, we're just going to take a value and we're just going to isolate it. So if we were to solve for sine squared, we would subtract cosine squared from our first sine squared plus cosine squared. So we would have sine squared of x equals 1 minus cosine squared. And this is if we just solved for sine squared. And so all I did was I subtracted cosine squared over to the other side. We could do the same thing for cosine squared and solve just for cosine squared. And so we would subtract each side a sine squared, and we would have 1 minus sine squared is equal to cosine squared. We can do the same things for 1 plus cotangent equals cosecant. So if we solve for just 1, we would subtract a cotangent from each side. So we would have 1 equals cosecant squared minus cotangent squared. Okay, cool. Likewise, we can solve for just cotangent. So we would subtract a 1 from each side, and we would get cotangent squared equals cosecant squared minus 1. And if so, if we were to solve just for tangent squared plus 1 equals secant squared, what is our trig identity going to be? If we were to solve just for tangent squared, we would have tangent squared x. What is that going to equal? Secant squared minus 1. Good job. And then likewise, we can solve for just 1. So we would subtract the tangent squared from each side, and we'd have 1 equals secant squared minus tangent squared. So these are just 2 other ways, or 6 other ways, of writing our original 3 trig identities. And by having these other manipulated forms of these trig identities, it will help us be able to solve some of these problems. And now we're going to get into the first practice problem because we want to just be able to get through at least the first page today. And so are you guys okay? And you have all these copied down? Thumbs up, thumbs down.
It says cotangent squared of x, is that equal to cosecant?
Yes, this is equals cosecant squared minus 1. Sorry if my writing is squished.
No.
How do you see much better?
You should sit in
I
the
couldn't
front
see
one.
that.
Are you guys okay with moving on? Thumbs up, thumbs down? Okay. So now we're going to use these to help us solve this, and we're going to solve for the general formula for all the solutions. So if you couldn't remember how to do that on the quiz, we're going to do it up here right now. And you do not need to know these, or you won't have to memorize these, I'm pretty sure. We'll give them to you.
Those 3.
These 3. Yeah. But the other ones. So when you tend to want to solve using a trig identity, it tends to be when you have when you have 2 trig identities that aren't the same. So we have a sine squared and a cosine squared in this problem. So we can't use a U substitution. We can't use a GCF. So we're going to have to use a trig identity. And if we notice, sine squared is equal to 1 minus cosine squared. And one way to remember, or one way to think on how I want to use my trig identity is I see what I have squared, if I don't have something squared, and if I don't have something squared, so we have just a cosine of x. It's not squared. So we want to get everything in terms of cosine of x so we can solve it. And so we need to get rid of this sine squared of x. And if we do that, if we remember, if we look back, or if you look just up, we have sine squared of x equals 1 minus cosine squared of x. And that's one of our trig identities. So we're going to replace or substitute sine squared of x with 1 minus cosine squared of x. And then this is plus cosine of x. This is equal to negative 1. So I just took my sine squared of x and I replaced it with 1 minus cosine squared of x because sine squared of x equals cosine squared of x from our trig identity. And now, what do you think we need to do? We want to get all of our things on one side, or all of our terms on one side, so we can solve for cosine squared of x. So we typically want to have a positive leading coefficient. So I'm going to get all my terms on the right side so I can get it positive over there. So I'm going to subtract by 1, add by cosine squared of x, and then I'm going to subtract by cosine squared of x. So it may seem like I'm doing a lot of work, but I'm just getting all my terms over to the other side. And so we'll have 0 equals cosine squared of x, and then we subtracted cosine of x, and then we had a negative 1 minus 1, so we'll have minus 2. Now what should be our next step that we want to try to solve this? What was this one? We want to try a U substitution. So we're going to let U, we're going to make it cosine, because our middle term, or the single, is cosine. So that looks like a good person to make u. So every time we see a cosine, we're going to turn into u. So we have u squared minus, oh, that's not what I want, minus u minus 2 equals 0. So every time we saw a cosine, we turn it into a u. And now we need to factor. And so what are going to be some factors, or what are the two factors that could work for this quadratic? So we need -2 and +1. So we'll have u minus 2 and u plus 1. And we see that -2 times 1 is -2, and -2 plus 1 is -1. So these are good factors. And these are both equal to 0, so we can set them equal to 0. So we have u minus 2 equals 0, and u plus 1 equals 0. And if you skip this step, that's good. I hope you can. And then we can solve for u by itself. And we get u equals 2, and u equals -1. Now that we have u by itself, we're going to see what we made u at the very beginning. And we said u was cosine of x. And so now when we see u, we're going to replace it back into cosine of x. We now have cosine of x equals 2, and cosine of x equals -1. And so when on our unit circle does cosine of x equal 2? It doesn't. So you can leave this blank, or you can write no solution. Either works. But now, when does cosine of x equal -1? At pi. So if we remember, the instructions asked us to solve for all the solutions and to give the general formula for all the solutions. So what do we need to add onto pi to make sure it's all the solutions? Plus 2 pi k. And that's because if we were to graph it, pi does not have a partner to make a diameter, and so we're going to add plus 2 pi k. And so this was a quick crash course into trig identities, but we'll work more of it tomorrow during the shortened periods.